Hi everyone. Today's seminar lesson, I'm going to walk you through some of the example how to solve trigonometric integrals. Okay, so before we get into the problems, I would recommend that you come back and review some of the trig identities or trig functions. It's really helpful when it comes to solve these kind of trig integrals problems. Okay, so those are Pythagorean identities, power reduction formula, and double angles. Okay. Okay. All right. So let's jump to the example. I have integral of 2 times quantity of tangent square x plus tangent to the 4x dx. Right. So here I see common factor. Right. I see common factor tangent square x. So I'm going to factor out. Tangent square x. What's left is 1 plus tangent square x dx. Okay, notice that this right here, that is secant square x, right? One of the trig identity right here. Let me highlight it for you. That one right there. Okay. Okay, so let me rewrite this function. So 2 integral of tangent square x secant square x dx. Now I can use up. Okay, now I can use up. I'm gonna let you equal tangent x. Why? Because when I'm taking the derivative of u, du is secant square dx. Okay. Square dx. Okay, so now I'm gonna put it back into the integral, into the integrand. So equal to, let's see, u now is tangent x, so tangent square x will be u squared. Secant square x dx, that's my du, right? So u squared du. Okay. Now we take the antiderivative of u squared, so we u to the third over 3 plus a constant. And now all we have to do is plug in the x term back. Okay, so equal 2 times u is tangent x, so be u cubed be tangent qx over 3 plus c. And that will complete our problem. Okay. Problem B, let me make a little division here. Okay. I have integral of 9x secant x tangent x dx. Okay, for this problem, I'm going to use integration by part. Right, so I'm going to let the u part equal 9x. So the u part equal 9x, and then the integral part, which is dv, part, the dv is equal to secant x tangent x, secant x tangent x dx. Okay, so for the u part, if I take the derivative, du is 9 dx. That's it. Right? Du is 9 dx. For the dv equals secant x tangent x dx, if I take the antiderivative of that, oops, I forgot the integral here. Sorry about that. Should have the integral side there. So v equal the antiderivative of secant x tangent x is secant x. Okay. Now remember, the integration by part has a formula of uv minus integral of v du. Right. All we have to do now is just plug it in. So plug it in there. U is 9x, so 9x. V is secant x minus integral of v du. Secant x du is 9x, 9 dx. Sorry, 9 dx. Okay. Right. So equal to 9x secant x. Then I'm gonna factor the 9 out to the front here. So the antiderivative of secant x dx is ln absolute value of secant x plus tangent x. And don't forget your constant. Okay. Okay, so for the last example, we have the integral from 0 to pi of sine square x minus sine cube x dx. Okay, for this integral, the first thing I'm going to do is I'm going to split this integral into two parts. Okay, so this one become integral from 0 to pi sine square x dx minus integral from 0 to pi sine cube x dx. Okay, so for the left part, maybe I'll denote in green this part right here. I'm going to use the power reduction formula. Okay, so let me remind you what is the power reduction formula right there. Sine square x equal 1 minus cosine 2x over 2. Okay, so or 1/2, or I'm going to factor out the 1/2. I'm going to factor out the 1/2 to the front, right? And now I have integral of 1 minus cosine 2x dx. And now we can integrate. Okay, so this is equal to 1/2. The antiderivative of 1 is x, right? Minus the antiderivative of cosine 2x is sine 2x over 2. Now, from this part, from the cosine 2x to this part, you can use U substitution, okay? But it just is so simple. I skipped that step, all right? And we're gonna evaluate from 0 to pi, okay? 0 to pi. So 1/2 times we're gonna evaluate the upper limit first. So pi minus sine of 2 pi over 2 minus the lower limit, which is 0 minus sine of 0 over 2. Okay, now sine of 2 pi is 0. Okay, so 0 divided by 2 is still 0, right? Still 0. There. Sine of 0 is 0. Divided by 2 is 0. So our final answer is, well, not quite final answer, but our answer for this part is pi half. Pi half. Okay. All right. Now for the other part, for the second part, maybe I'll code it in blue. I'll code in blue. Let me divide this. Okay, so for this part, what I'm going to do is going to rewrite this sine qx as, I'm going to rewrite this as sine x times sine square x. Okay, now we know that sine square x is equal to 1 minus cosine square x, right? One of the Pythagorean identity, right? So this one right here, let me rewrite this, is equal to integral from 0 to pi sine x times quantity of 1 minus cosine square x dx. Okay, so what I'm going to do next is I'm gonna let u equal cosine x. So that means du is minus sine x dx. Sine x dx. Oops, sorry. Sine x dx. Or better yet, minus du equal sine x dx. Okay. All right, now here, this block right here, that's our minus du. Okay, that's our minus du. So this one become minus du, and the inside the parenthesis is 1 minus u squared. 1 minus u squared. Now remember, we're writing things in terms of u now. So the limit has to be in terms of u's also. Okay, so I have to change the limit. Now u sub 0. What I'm going to do, I'm going to plug into this function here, right? So cosine of 0 is 1. So u sub 0 is 1. And u of pi, cosine of pi is -1. So now our new limit is from 1 to -1. 1 to -1. Okay. Okay, so now we can integrate. So actually before I integrate, I'm gonna distribute the negative. So if I distribute the negative inside the parentheses, I have integral of u squared minus 1 du, limit from 1 to -1. Okay, and now I can integrate. So be u cubed over 3 minus u, evaluate from 1 to -1. Let me rewrite this one. So upper limit first, I have, if I plug in -1 for u, I have -1 cube, -1/3 minus -1, which is +1, right? Minus the lower limit, which is 1/3 minus 1. -1/3 plus 1 is 2/3, right? Is 2/3 minus -2/3. So minus is plus, so I have 4/3 at the end. Okay, and now we're going to combine the results together. So the final answer here is pi half plus 4/3. That's our final answer. Okay. All right. So these are some of the example how to solve the trigonometric integrals. Thank you for watching.